All right, continuing our work with section 1.2. Last Friday, you did a whole bunch of solving equations, and we had the concern about variables in the denominator. We had to look for any domain restrictions. For example, in this first one that we are doing today, what would our domain restrictions be? X can't be 5 or negative 5, right? So what would happen if we got one of those answers? What did we have to say? There's no solution. All right. So what we're going to look at today is those different kinds of equations where maybe we don't get a solution, or maybe we get all real numbers working. Okay? So we're going to have kind of a mixture. We're going to look at how we classify them. Are they identities, conditional equations, or inconsistent equations? And then we're going to look at some applications. All right. So for our first one, what's the process we use to get rid of the denominators that we used last week? You guys just worked through this. What'd you do? Okay, we look for that common denominator. In this case, what would the common denominator be? Okay, so we have an x plus 5 and an x minus 5. We're technically not getting common denominators for all of our fractions. We're trying to use it to eliminate the fraction part. Okay, so if we multiply every single term by that common denominator, all of the denominator pieces should drop out. Okay, when we multiply it to the first one, the x plus 5 piece would drop out. We still have a 4 and an x minus 5 left for that one. When we distribute to our second term, our x minus 5s will now drop out. We still have the 3 and the x plus 5 left. When we distribute to the third one, everything should drop out because x squared minus 25 is equivalent to x plus 5 and x minus 5. So all we would have left is the 32. We okay so far? All right. Distributing, we've got 4x minus 20 plus 3x plus 15 equals 32. Combining like terms on the left-hand side, we get 7x minus 5. And then we simply have to add the 5 over and divide out our 7. Okay? Remember last week we talked about putting that in those set brackets? So our solution set is just the set containing 37/7. All right, so this is an example of what we would call a conditional equation. A conditional equation is one where you get at least one answer, right? It works for at least one real number. Okay? In other words, the equation is true on the condition that x has to be 37/7. Okay? So when you can get an answer, we say it's conditional. An identity is an equation that is always true. It works for every real number. Doesn't matter what I plug in for x, it will always work. Inconsistent is the opposite. It's never going to work. There's no solution that makes that equation true. All right, I'm going to pause the recording, give you a minute to write those down. All right, so we're going to look at three pretty basic equations to solve, but our goal here is to identify which type of equation it is. Is it an identity that always works? Is it inconsistent where it never works? Or is it conditional where it works for some x's? All right, so our first one, we simply have to subtract 3 and divide. So in this case, we are getting a solution. All right, so we would say this one is conditional. All right, it works on the condition that x has to be a 7. Okay. For the next one, if we combine like terms on the right-hand side, we end up with the statement x plus 3 equals x plus 3. The two sides are identical. If we were to try to solve this for x, we'd have to get our x's to one side. Subtracting an x from both sides makes them disappear. So we end up with the statement 3 equals 3. Okay, we're going to come back to that one in just a minute. If we tried to do the same thing over here where we were trying to solve for x, I'd try to get my x's to one side. Subtracting an x to the left-hand side leaves me with nothing equaling 7 on the right-hand side. In both of these examples, the variable's gone. I cannot solve for x if there's no x, right? But we have two completely different resulting statements. In the first one here, we have 3 equals 3. That is a true statement. If we have our variables disappear, but we have a true statement left, that is called an identity. Okay, it is always going to work. X plus 3 will always equal x plus 3. Doesn't matter what I plug in for x, it will always work. The third one here, we have a false statement. 0 does not equal 7. That means there is no x that I can plug in that's going to make x equal x plus 7. Okay? If we get a false statement, these are the ones we say are inconsistent. And what you would give me for a solution in this case, you'd say no solution. Or you can do the empty set brackets. Okay? Both of those mean the same thing. What happens when it's an identity? Do you guys remember ever using what we call set builder notation? We've been giving our answer with the set brackets. Okay? If our answer is that all numbers work, every real number is going to make that a true statement. How we write that looks like this. Okay? We would say x such that x is a real number. Now, I don't have to write it out is a real number. I can do this. X such that. That's what that bar means, okay? X such that x equals a real number. We use that capital R to represent the set of real numbers. So as you go through the examples today and your homework questions, if you get an answer, conditional, okay, write that answer in set notation. If your variables disappear, you have to analyze. Am I left with a true statement or a false statement? If it's true, you're going to write this. It's an identity. All real numbers work. If it's a false statement, it's inconsistent. No answer is going to ever work. Okay? All right, so we have a few examples to work through. Again, we're going to classify what type of equation it is, as well as trying to figure out what the solution is. So what would we do on our first one? First step. Distribute. Okay, if we distribute, we've got 2x minus 12 plus the 7 equals 2x minus 9. Combining like terms. The negative 12 plus the 7 would be negative 5. And what's going to happen? What happens to our variables? They're going to disappear, right? We subtract 2x from both sides, they're gone. Our statement that's left is negative 5 equals negative 9. Is that true? Does negative 5 equal negative 9? No. So we get a false statement. What does that tell me? It's inconsistent, which means no solution. Okay. Looking at example 2, if we distribute, we get 6x plus 6 minus 2x on the right-hand side. Combining like terms gets me 4x plus 6. Does 4x plus 6 equal 4x plus 6? Yes. Combining our x's together, they would disappear. We're left with 6 equals 6. Because we have a true statement, what would we say? It's an identity. And how would we write our solution? This is the long one. X such that X has to equal all real numbers. Yep. All right. Our next equations get a little more complicated. Again, we're looking for, is it consistent? Is it, or conditional, I should say. Is it conditional? Is it inconsistent? Or is it an identity? Number 3 here is similar to the very first one we did as a review from last week. We are going to need a common denominator to multiply through so we can get rid of all of our fractions. What would our common denominator be? All right, we need a 2x plus 3 and we need an x minus 1. What would we have for domain restrictions? In other words, what x's do we have to be careful not to use? What makes our denominator 0? 1 or negative 3/2? Okay, so we have to watch out for those. Distributing to our first term, the x minus 1's drop out. We're going to have 1 times x times 2x plus 3. For our second term, both denominators will drop out and we're left with just a 1. When we distribute to the third term, the 2x plus 3's would drop out. We do have a 4 and an x minus 1 left. Okay, so by multiplying by that common denominator, we've eliminated all of our fractions. What's our next step? What's our next step? Distribute, okay. We end up with 4x minus 4 for that piece. Okay, combining like terms, we get 4x minus 3. Getting variables to one side, I could subtract 2x from both sides. I'm left with 2x there. I could add 3 to both sides. That gives me a 6 on the left, which means x is going to end up being a 3. Since we got a solution, and it isn't one of our restricted ones, right? It's not one that it can't be. So we would say this one is conditional. And the condition is that x has to be a 3. All right, our next example has some decimals in it. Don't let that make it more complicated. 0.5 is 1/2. If we take 1/2 times x, we get 1/2 x. If we take 1/2 times 2, we get 1. On the right-hand side, we have a 1/10. And then we have a 3 here that we have to distribute. So 3 times 1/10 x would be 3/10 x. 3 times 3/10 would be 9/10. Combining like terms, what's 1/10 and 9/10? It's just a whole. All right, so we end up with 1/2 x plus 1 equals 3/10 x plus 1. Can we get our x's together? Okay, if I subtract 3/10, I'm left with 2/10. If I subtract the 1 to the other side, I'm left with 0, which is okay because my next step is divide out 2/10, and 0 divided by anything is 0. So I end up with the condition, right? X has to be a 0. So this is a conditional equation. And our condition is that x has to be 0. All right. Question 6 has a lot of grouping symbols. We need to start from the innermost one and kind of work our way out. Grouping symbols are often in there to indicate that you have something to distribute, but we have to think of order of operations, all right? Parentheses have to be simplified before we do any distributing. So starting with the very innermost set of parentheses, which would be right here, what is it asking me to do? Why are there parentheses there? They're telling me to distribute that -2. Okay, so we're going to keep everything else the same. Distributing the -2 gets me -2 plus 2x. Everybody agreeing so far on that? All right, now I have the next set of parentheses. Do I have some like terms that I could simplify inside first? I'm looking at this section right here. Yes? Let's get that simplified. What do we get? 4 minus 2 would be 2, plus the 3 would be 5. So we end up with 2x plus 5. Okay. Now why are the parentheses there? I've combined the stuff inside. What is it telling me to do? Distribute a negative. All right. So I'm going to have 7 minus 2x minus 5. Now, inside the brackets, combining like terms gets me 2 minus 2x. And then to eliminate the brackets, I have to distribute my -2. Okay, agree on how we've simplified the left side of that. Okay? All right, let's go back up to the right-hand side. We have a plain 10 that's out front here. We're going to just leave it there for a minute. Inside all of these brackets, what am I being told to do? Distribute what? A -2 in here. Okay, so we'll have 4x minus 2x plus 6. Inside the brackets now, if we combine like terms, we would have 2x plus 6. Okay, distributing the negative so we can get rid of the brackets. We'll have 10 minus 2x minus 6. And combining like terms, we end up with what, -2x plus 4. So now we have the equation -4 plus 4x equals -2x plus 4. If we add the 2x over to the left side, we have 6x. If we add the 4 from the left over to the right side, we get an 8. And when we divide, we end up with 8/6, which reduces to 4/3. What type of equation would this be? It is conditional because we got a solution. All right, so conditional equation, and the condition is x has to be 4/3. Okay? All right, your homework is going to be 57 to 79 odd and then 89 to 99 odd. We are going to do 57 together, so I'm going to pause the recording while you get this written down and get your homework sheet out and write down number 57. All right. To get started, notice that on the left side, all we have is a 0. So we really just have one side of this equation we have to do some simplifying on. All right, on the right-hand side, starting with the innermost bracket would be this piece right here. All right, we've got 3 minus an x. Why is the parentheses around that? Distribute the negative. All right, so we have 4, a bracket, x minus a 3 plus another x. Okay, inside the brackets, we have 2 different x's that we could put together. Make this a 2x minus 3. And then how do we get rid of the brackets? What do we have to do? Distribute the 4, yes. So 4 times the 2x would give us 8x. 4 times the negative 3 would be negative 12. On the second half of this side here, we've got a 7 or a negative 7 in front of x plus 1. To get rid of these parentheses, we have to distribute that negative 7. So we would end up with negative 7x minus 7. Okay. Combining like terms, we end up with x minus 19. So we can solve it. X is going to equal 19. So it is called what type? Conditional. Okay. All right. So again, you are working on 57 to 79 odd, 89 to 99 odd. I want you to be able to check your answers, but obviously there's some work to be shown to get to those answers.